Hello class. In this lecture I will be talking about hypothesis testing for two population means using tstat, and then I will try to solve a one tail problem in this. I will try to explain this concept using the following Hawk's learning problem. So the question says a manufacturer claims that the calling range in feet of its 900 megahertz cordless telephone is greater than that of its competitor. A sample of 12 phones from the manufacturer has a mean range of 1150 feet with a standard deviation of 27 feet. A sample of 7 similar phones from its competitor had a mean range of 1100 feet with a standard deviation of 23 feet. To the results support the manufacturer's claim, let mu1 be the true mean range of the manufacturer's cordless telephone and mu2 be the true mean range of the competitor's cordless telephone. Use a significance level of alpha is equal to 0.01 for the test. Assume that the population variance are equal and the two populations are normally distributed. So here the first thing is they say they tell us to assume mu1 be the true mean range of the manufacturer's cordless phone. So mu1 represents manufacturer's phone, so I will just write manufacturer, and mu2 represents the competitor. So when we do hypothesis testing, the first step is to define our hypothesis. So when we define our hypothesis, we have H null and then we have H alternative. So they say that the manufacturer claims that the calling range of its 900 megahertz cordless telephone is greater than its competitors. So this is an alternative. So they are claiming that they are better than their competitors. So your mu1 manufacturer will be greater than mu2. So the other way of writing this is mu1 minus mu2 is greater than 0. So the null hypothesis will be opposite of this, which will be mu1 less than or equal to mu2. So that means your mu1 minus mu2 is less than or equal to 0. So that we can write this expression like this. So once we define our hypothesis, the second step is the data is given. We will take that data and copy it. So let's see what the data says. So this is all given. So we have manufacturer's data, and then we have competitors' data. So let's see what did they say about manufacturer. A sample of 12 phones from the manufacturer had a mean of 1150. Sample is 12, so our n1 is 12 and the mean is x1 bar would be 1150, and then the standard deviation is 27 feet. How about competitor? So they say a sample of 7 similar phones from its competitor. So N2 is 7, and then X2 bar is given as 1100 feet, and then the standard deviation S2 is 23. So, and then they wanted us to do hypothesis testing at a significance level of 0.01. So alpha will be 0.01. So to determine which test is this problem, the first thing is we look at, so we have S1 and S2 given, so we don't have sigma 1 and sigma 2. So sigma 1 and sigma 2 are unknown, and then our sample size n, this is 12, which is less than 30, n1, and this n2 is 7, is less than 30. So when we have n1 n2 less than 30 and sigma 1 and sigma 2 are unknown, which is population, standard deviation for manufacturer and competitor are unknown, so we will be using tstat. So the next step of hypothesis testing is to compare the test statistic with critical value. So irrespective of whatever one tail or a two tail problem, the test statistic formula will always be same. So in this case we are using tstat, so the test statistic formula will be x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sp square 1 by n1 plus 1 by n2. So the next step is to calculate sp square. This is pooled variance. So this is pooled variance or common variance. So we will be calculating it. So common variance sp square, the formula is n1 minus 1 s1 squared plus n2 minus 1 s2 squared divided by n1 plus n2 minus 2. So this sp squared, so n1 is, so if you look at n1 is 12, so I will write 12 minus 1, s1 square is 27, so this will be multiplied by 27 square plus n2, so n2 is 7 minus 1 s2 squared, again this is s2 is 23 multiplied by 23 squared divided by n1, which is again 12 plus n2, which is again 7. So if you at this 7 minus 2. So this we will obtain 658.4118. So we will take this and put it here in SP square. So now t value x1 bar is given as 1150 minus x2 bar is given as 1100, mu1 minus mu2, this is going to come from our hypothesis, so this will be this value, which is minus 0 divided by square root of SP square is 658.4118. 1 over n1 is, again n1 would be 12, 1 over 12 plus this would be n2 would be 7, so that is what. So let me calculate this. I'll calculate this. So this value would be 4.09. So we got our t value, test statistic value, which is 4.09. So the next step is to compare it with critical value. So the critical value is this. So I will do critical value in the next page. So to get critical value, you have to determine whether this is a one-tail problem or a two-tail problem. So that is what. So if you look at it, if it is, we are looking at our hypothesis, and our hypothesis is less than or equal to, so this is a one-tail problem, so we are looking on one side of a normal distribution curve. So so if it is one-tail problem, our critical value will be T alpha degree of freedom n1 plus n2 minus 2. So this is what we need to calculate. So let me show how our hypothesis will look in a normal distribution curve. So here is our normal distribution curve, and then this is mu1 minus mu2 is equal to 0. So our hypothesis is mu1 minus mu2 less than or equal to 0. So that is what our hypothesis is, if you see here. So this is mu1 minus mu2 less than or equal to 0. So it's less than certain value. So I will do here certain value, and less than value. So this is a null hypothesis curve, H null. So anything less than this certain value will be do not reject H null. So that means if our test statistic value falls in this region, your mu1 minus mu2 will be less than or equal to 0, or the other way of saying is your mu1 is less than or equal to mu2. That means the manufacturer's range is less than the competitor's range. So if we look at the other side, so this area, this will be again our significance level. They gave us 0.01 alpha, so this will be, because it's a one tail, we directly consider alpha. This will be a reject H null. So when we say reject H null, that means our alternative would be true. So our alternative, which is mu1 minus mu2 greater than 0. So in this region, so if I write alternative mu1 minus mu2 greater than 0, in this region mu1 minus mu2 is greater than 0, so mu1 will be greater than mu2. So this is manufacturer will have higher range compared to the competitor. So again this would be 99% because, or 0.99, because this is 0.01. So now I wanted this point to be calculated, so I will the critical value. So this would be T alpha, which is 0.01. So I'm looking for T alpha n1 plus n2 minus 2. So this is T 0.01. n1 is n1 would be 12. Yeah, so n1 is 12 plus n2 is it is 7. So I will do this is 12 plus 7 minus 2. So we are looking for T value 0.01. 19 minus 2 is 17. So this value here, T 0.01 17, whatever value we get from T table will be this value, will be this point. So we go to our T table and look for T 0.01 and 17. So I'm going to Canvas, go to modules, and then go to calculation aids page and download statistical tables. And then do enable editing. So currently I am in a Poisson table. I need to go to T table. So I go to T table and then I am looking for T 0.0117. So let me cross check this. Okay, T 0.0117 is what I am looking for. So I will go here and T 0.01 is this value and the degree of freedom 17 is this value. So my T value would be 2.5669. So this is 2.5669. So this point would be 2.5669 in a number line. Now I'm looking for the T value 4.09. So where does 4.09 lie? Or does it lie to the left of 2.5669 or to the right? 09 would obviously be to the right in a number line uh, of 2.5669. So it falls under reject H null region. So mu1 is greater than mu2. So when I say mu1 is greater than mu2, that means manufacturer's coverage, manufacturer's range is greater than competitor. So in conclusion, so the question asks to test for whether the manufacturer's claims that the calling range is greater than that of its competitor. Yeah, that is true. So we say there is sufficient evidence. So this is the conclusion we are going to make. There is sufficient evidence to claim that the manufacturer's range is greater than competitor. So that is what the claim would be, and then that would be our conclusion. Now we can solve the same problem using our calculation aids. So I will go to the next page and try to, maybe I can use this same page and try to note down all the things that are given. So in our calculation aids we will also need hypothesis. So I will go and copy including hypothesis. So I will copy from here until this point all the information. So our H null, so our hypothesis is, so this is using calculation aids, I'm solving it. Our hypothesis is mu1 less than or equal to mu2. So mu1 minus mu2 is less than or equal to 0, and our alternative is mu1 greater than mu2. So this will be mu1 minus mu2 greater than 0, and given data is manufacturer, which is sample 1 of our, if you type in, you will type in sample 1, and this is competitor, this will be sample 2. So n1 is 12, x1 bar is 1150, and then s1 is 27, and for the second part n2 is 7, x2 bar is 1100, s2 is 23. So once we have these, we need alpha, which is 0.01. So once we have this, I will key in these values into our calculation aids. So I go here and then go to modules, module 0, and then calculation aids, and chapter 11 calculation aids. So I have this. Now which sheet to use? Known variance or unknown variance. So since we have, if you go to our sheet, we have our sample standard deviations, our sigma 1 and sigma 2, which is uh, population standard deviations, are unknown. So the other way of saying this is population variances are unknown. So variance and population standard deviation are one and the same. It's just variance, standard deviation is square root of variance. So variance are unknown, so you will kind of use unknown variance sheet. Okay, let me, so you are using unknown variance sheet. So you go to unknown variance sheet, and then your, let me see what values we need first. So in this gray area you will be typing in the values. So the first thing is we need is sample mean for sample 1. So sample mean for sample 1 is 1150. So I will do 1150 here. So this is 1150, and then the sample standard deviation is 27. So I will do 27, and then sample size so sample size n1 is 12. So now sample 2, sample mean for sample 2. So sample mean would be 1100. So this is 1100, and then sample standard deviation is 23. And then sample size is 7. And then alpha is 0.01. So again we have a SP square of 658 test statistics 4.09, and then okay, this is, I need to hit enter. So the critical value we have here, we have confidence interval here, we have standard error. So this is now which one to use. So whether we wanted to use this one as a one tail or this one. So now we go to our hypothesis and look for what is our hypothesis, alternative hypothesis. So our alternative hypothesis is mu1 minus mu2 greater than. So I will go here and mu1 minus mu2 greater than is this. So I will be using these values. So my critical value would be 2.56 and I reject null hypothesis. So when I reject null hypothesis, so this is false, so that means it inherently we are saying this is true. That means manufacturer's capability is better than the manufacturer's range is better than the competitor's range. So this concludes my lecture on hypothesis testing for two population means using tstat, and I tried to solve one tail problem. Thank you.